Hello again everybody. On this video we're going to be covering solving inequalities. That's chapter 1 section 4 in your algebra 2 book. When we work with inequalities, sometimes our natural instinct is to fear these new signs because there's so many of them, but just remember that in English, just like equal sign means is, the less than sign literally means is less than. Well, the greater than sign means is greater than, or less than or equal to, or is greater than or equal to. These are just symbols that represent words we understand. The good news is there's only one difference in solving equations versus solving inequalities, and that is if you multiply or divide each side by a negative number, you must flip the inequality. That means you pretty much can solve problems with inequalities in them. We're going to be doing some problems pretty soon, and you'll see that at work, that rule that only applies for inequalities. So let's start with solving 3x minus 12 is less than 3. And then we're going to solve 6 plus 5 times the quantity 2 minus x is less than or equal to 41. Basically, we want to figure out what values of x we can plug in here to be less than 3. Obviously, there's a lot of different answers for that. If we plug in 0, for example, 3 times 0 is 0 minus 12. 0 minus 12 is negative 12, so that's an answer. 0 is a solution. We have to find out all the possible solutions. We want to solve this inequality for x. And this is the same as if this was an equal sign. First we start by adding 12 to both sides. We got 3x equals 15, and so we're going to divide each side by 3, and x is 5. Now it doesn't equal 5. That's the cutoff point. What that means is all numbers less than 5 are solutions. My solutions are all less than 5. 4 works, 3 works, 2 works, 1 works, 0 works. All those numbers work. When we go to this one, we need to do a little simplifying before we solve. First we need to distribute the 5. So we're going to distribute the 5 times 2 is 10, minus 5 times x is 5x. Bring down the 6 and the plus, less than or equal to 41. Combine like terms, we get 16 minus 5x is less than or equal to 41, and then we solve minus 16 minus 16, negative 5x equals 25. So, it's less than or equal to 25, bad habit. And so this case, I'm going to put this up here, is one where we have to use that special rule. We divide by a negative on both sides, and so that means we flip the inequality. That means we're going to have x is greater than or equal to negative 5 as our solution set. So you try. Solve 12 is greater than or equal to 2 times the quantity 3n plus 1 plus 22. Remember, simplify by distributing first. Go ahead and pause it and do it. The answer could be A, n is less than or equal to negative 7, B, n is less than or equal to negative 2, C, n is greater than or equal to negative 6, or D, n is greater than or equal to 3. For practice on problems like this, you want to do page 29, numbers 1 through 9 all. Next example, example 3, we're going to be looking at inequality story problems. A band agrees to play $200 plus 25% of the ticket sales. Find the ticket sales needed for the band to receive at least $500. The key word here to know that this is an inequality is these words, at least. Now this can be kind of deceiving because when we create our inequality, you think least, you think less. But in fact, you're trying to find a profit that is greater than 500. So you're actually going to use the greater than or equal to side, depending on how you set it up. We want to make $500 or 501 or 510. There's lots of different solutions. Anything above 500 is a solution. How do we make this inequality? Put all the profits on the left side and the total on the right. And then make sure you choose your inequality signs like we talked about. Make sure that you get it right. So here's what it would be. $200 and 0.25x would be our profits. Basically, if we made $100, we'd go 0.25 times 100 and it would get us $25. 25% of $100 is $25. If we add 0.25 times 200, that'd give us $50. So basically, you're plugging in how many tickets you sell, adding or multiplying it by 25%, and then adding the $200 you get for the agreement. Now the question is, do you want this profit to be greater than 500, or do you want this profit to be less than 500? Of course, you want the profit to be greater than 500 or equal to 500. So the question is, what are your solutions, or how many tickets do you need to receive $500? And the answer would be 75. When you solve this, you're going to subtract 200. You got 0.25x is greater than or equal to 300. You divide by 0.25, and you're going to get, it's got to be more than 75 tickets. So you could have 75 tickets, or 76 tickets sold, or 77, 78, etc. So here's your turn. A salesperson earns a salary of $700 per month plus 2% of the sales tax, basically 2% at what he sells. What must his sales be if the salesperson is to have a monthly income of at least $1,800? So you want $1,800 or $1,801 or anything greater than $1,800. It could be A, 55,000 or more, B, 43,000 more, C, 100,000 or less, or D, $43,000 or less. Go ahead and try now. For more problems like that, you will want to try page 29, number 17. Example 4, you're talking about now inequalities that have two different problems in one. Compound means two in one. Compound word is two words put together to make one. A compound inequality is two different inequalities put together to make one. In this case, we're talking about and inequalities, which means both. Both of the inequalities have to work for x. So if x works for one of them, it has to work for the other one to make it a solution for the compound inequality. So if we solve 3x minus 1 is greater than negative 28, and 2x plus 7 is less than 19, what we need to do is figure out what works for this one and this one. We're going to list 3 solutions and 2 non-solutions. I could guess and go 3 times 0 and 2 times 0. 0 minus 1 is negative 1. That's greater than 28. And 2 times 0 is 0, plus 7 is less than 19. 0 is a solution. Okay, we've got to find a couple more, but to find all the solutions and non-solutions, it's best to find the cutoff points. So what we're going to do is we're going to solve. Add 1 to that side, subtract 7 to that side, cross them out. We have 3x is greater than negative 27, 2x less than 12. Divide each side by 3 and 2, cross them out. We've got x is greater than 9 and x is less than 6. So what numbers satisfy both requirements that x is greater than negative 9 and x is less than 6? An example could be negative 8, 0, and 5. Because 0 is greater than negative 9 and less than 6. Negative 8 is greater than negative 9 and is less than 6. Etc. and so on and so forth. Two non-solutions would be negative 10 and 7, because negative 10 is less than 6, but it's not greater than negative 9. 7 is greater than negative 9, but it's not less than 6. It's got to include both. So you try. Find 3 solutions to the compound inequality. 2x is greater than x plus 6 and x minus 7 is less than 2. It could be A, negative 6, negative 7, and negative 8 are solutions. B, 6, 7, and 8.5 are solutions. C, 6.4, 7, and 8 are solutions. Or D, 2, 5, and 7 are solutions. For more problems like that, please do page 29, numbers 18 through 21 all. Last example, we're going to look at compound or inequalities, which means either. The solution, if it works for one, it works for the entire thing. One or the other, or it could work for both. Both works also. So either kind of includes and, but it adds on one or the other. So a solution to this set would be anything that we could plug in here, or anything you could plug in here, or you could plug it into both. It doesn't matter that they don't have to be both. It could be both, but it doesn't have to be. It could be just this one or just this one. Okay, so we're going to solve it the same way. Add 2 on this one and add 4 on this one. Cross them out. We got 4y is greater than or equal to 16 and 3y is less than or equal to negative 9. Divide by 4, divide by 3. And you got y is greater than or equal to 4 or y is less than or equal to negative 3. So solutions that are greater than or equal to positive 4 or less than or equal to negative 3 are 5, because that's greater than or equal to 4, or negative 10, that's less than or equal to negative 3, or 18. Non-solutions would be like 0 and 2, because it doesn't work for either of them. Alright, so try these ones. X minus 1 is less than 3, or x plus 3 is greater than 8. Find solutions that work for either or both. The answer could be A, 2, 3, and 4, B, 4.5, 6, and 10, C, 1, 3, and 5, or D, 0, 3, and 7. Go ahead and try now. What you want to do for practice is page 30 to number 22 through 25 all. And that's it for solving equations. Or sorry, solving inequalities.